Hello everyone and welcome to the lesson on Vertex AI. So Vertex AI, if you want to remember from a diagram, just remember this diagram. It's a unified data science and machine learning platform for all skill levels. So the center circle is data and model management, which is basically data management, data engineering, and then comes the machine learning model management. So it includes all phases. So we have machine learning development, training, operationalization, continuous training, model deployment, prediction serving, and continuous monitoring of your machine learning model. So typical machine learning workflow looks something like this. You start with preparing your training data, then you create a data set. So preparing is the most important aspect, wherein you clean the data, you remove nulls, invalid values, all those things. Then you, after create a data set, you train a model, then evaluate and iterate on your model, then get predictions from your model, and finally interpret prediction results, and then you stop. This is a one cycle. Then you repeat this cycle based on your model quality of your model. And the key features. Okay, now coming to the key features of Vertex AI. It's a unified user interface for the entire machine learning workflow. It offers pre-trained APIs for vision, video, natural language, and more. So all this is part of Vertex AI. So Vertex AI is like all-in-one shop for everything machine learning, be it pre-trained APIs or your custom development. It's an end-to-end integration for data and AI. So it integrates with all your data services. It support for all open source frameworks, end-to-end application development environment. And we'll see now, we'll dig deeper into each feature. Unified UI for the entire ML workflow. So Vertex AI brings together the Google Cloud services for building ML under one unified UI and API also. So it offers API as well. In Vertex API, you can now easily train and compare models using AutoML or custom code training, and all your models are stored in one central model repository. These models can now be deployed to the same endpoints on Vertex AI. So pre-trained APIs for vision, video, natural language, and more. So easily infuse vision, video, translation, and natural language machine learning into existing applications, or build entirely new intelligent applications across a broad range of use cases, including translation and speech to text. AutoML enables developers to train high quality models specific to their business needs with minimal ML expertise or effort, and with a centrally managed registry for all datasets across data types. So it can be vision, natural language, and tabular. So pre-trained APIs, as I talked about before, that it's like there's an API and you don't have any coding involved. There's interfaces available. You just submit your object. It can be video file, it could be photos, it could be images, it could be text, it could be transcript, and it can just give out the expected result via like JSON response, and you can just embed or integrate with your applications very easily. Now end-to-end integration for data and AI. Through Vertex AI Workbench, you will dig deeper about AI Workbench. Vertex AI is natively integrated with BigQuery, Dataproc, and Spark. You can use BigQuery ML to create and execute machine learning models in BigQuery using standard SQL queries on existing business intelligence tools and spreadsheets. Or you can export data sets from BigQuery directly into Vertex AI Workbench, and run your models from there. And you can use Vertex data labeling. So this is also like the data labeling services is available. So you can upload tons of images and all. So data labeling service will help you label those data to generate highly accurate labels for your data collection. And it supports for all open source frameworks. So Vertex AI integrates with widely used open source frameworks such as TensorFlow, PyTorch, scikit-learn, along with supporting all ML frameworks and artificial intelligence branches via custom containers for training and prediction. And end-to-end application development environments. So let's see what is that. Vertex AI Vision reduces the time to create computer vision applications from weeks to hours at 1/10 the cost of current offerings. It provides an easy-to-use drag-and-drop interface and library of pre-trained ML models for common tasks such as occupancy, counting, product recognition, and object detection. also it provides the option to import your existing auto ML or custom ML models from Vertex AI. So this is also available. You can actually import from other places as well to auto ML or custom ML models from Vertex AI or from some any other resource as well. So auto ML helps you easily developing high quality custom. So auto ML is some kind of a mix between you have some coding and you have like there's some help from the cloud APIs as well as. So you can easily develop high quality custom machine learning models without writing training routines. And it is powered by Google's state-of-the-art transfer learning and hyperparameter search technology. So this is where the transfer learning comes in. So let's say you have some object detection. Let's say this is one example, and this transfer learning. So there are already available existing models which can detect, for example, object recognition or image recognition. And that you can bring in, and you can do some additional on top of that. And then finally you will come up with the model which will have a very strong baseline, and then you build something on top of that. And it offers, and also this is a hyperparameter search technology. So when we do machine learning, there is a lot of hyperparameter tuning, and this can be made easier because of AutoML, because it's very highly optimized. So deep learning VM images instantiate a VM image containing the most popular AI frameworks on a compute engine instance without worrying about software compatibility. Okay, now we are going other features one by one, like smaller features. So this option is already there in the Vertex AI, that the VM images are available with all your version AI frameworks, libraries already pre-configured. You just have to start using that within the Vertex AI. So Vertex AI Vizier. So Vizier is optimized hyperparameters for maximum predictive accuracy. So there is already because data scientists or machine learners have to spend a lot of time in hyperparameter tuning, but it's already optimized. So you just configure like how you want, what is your model, what you want to predict, and it can automatically start with some kind of optimization. So you can save a lot of time. Now, Vertex AI Workbench, we have already talked a bit, but Vertex AI Workbench is the single environment for data scientists to complete all of their machine learning work, from experimentation to deployment to managing and monitoring models. It is a Jupyter-based, fully managed, scalable, enterprise-ready compute infrastructure with security controls and user management capabilities. Next feature is Vertex AI Matching Engine. It's a massively scalable, low latency and cost efficient vector similarity matching service. Vertex AI Data Labeling. So get highly accurate labels from human labelers for better machine learning models. So imagine you have millions of photos and you want to label them. So you can submit there, and this get labeled by human labelers. Vertex AI Deep Learning Containers. Quickly build and deploy models in a portable and consistent environment for all your AI applications. So deep learning containers are available so that you can run your job again and again, and you don't have to run on real virtual machines. So it just makes it easier, and you can have much better CI/CD control as well. Vertex Explainable AI. So understand and build trust in your model predictions with robust actionable explanations integrated into Vertex AI Prediction, AutoML tables, and Vertex AI Workbench. So this explainable AI is integrated with all these AI prediction, AutoML tables, and Vertex AI Workbench. Basically, it will tell you about all your features, how they affect your score. For example, your true positive rate, true false positive rate, all those things. It can explain like which feature have impact and how the model is performing, all those things. So this all explanation is given by this feature, Explainable AI. Now Vertex AI Feature Store. It's a fully managed, rich feature repository for serving, sharing, and reusing ML features. Vertex ML Metadata. It's an artifact lineage and execution tracking for all ML workflows with an easy to use Python SDK. So just sorry, there's a lot of features that we have to go through. We will not dig deep into everything, but from the exam point of view, like some of the features may show up, so we just have to remember, okay, this feature is available and this is what the name is there as per the documentation. So that's why this lecture will be a bit long, because there are too many things to be covered from the examination point of view. And this is for the data engineering exam, this will be one of the things, but we must be knowing like all the features that is part of Vertex AI. So Vertex AI model monitoring, so it automated alerts for data drift. So there's a lot of time data drift happens because of model, there's new data coming in and it's not giving results as it used to be before. So it can detect data drift, concept drift, or other model performance incidents which may require supervision. So Vertex AI and neural architecture search, build new model architectures targeting application specific needs and optimize your existing model architectures for latency, memory, and power with this automated service powered by Google's leading AI research. So now one of the important concepts is Vertex AI pipeline. So if you know from DevOps point of view, like there are CI/CD pipelines, right? So CI/CD is continuous integration, continuous deployment, delivery pipelines. So it takes care from you submitting your code to version control all the way to deployment to production or QA. So just imagine this similar for AI pipelines. So build pipelines using TensorFlow extended and kubeflow pipelines, and leverage Google Cloud's managed service to execute scalable and pay per use. So this pipeline basically is like you change something, everything gets deployed, tested, everything, and it starts serving. There's an endpoint also available, and it starts serving production results immediately. So streamline your ML ops with detailed metadata tracking, continuous modeling, and triggered model retraining. Vertex AI prediction, deploy models into production more easily with online serving via HTTP or batch prediction for bulk scoring. Vertex AI prediction offers a unified framework to deploy custom models trained in TensorFlow, Scikit, or XGBoost, as well as BigQuery ML, AutoML models, and on a broad range of machine types and GPUs, graphical processing units. So Vertex AI TensorBoard, this visualization and tracking tool for ML experimentation includes model graphs which displays images, text, and audio data. So basically this is a dashboard. So every time you submit a model, you can see all information of how the model has performed and all the real-time information. Vertex AI training provides a set of pre-built algorithms and allow users to bring their custom code to train models. A fully managed training service for users needing greater flexibility and customization, or for users running training on premises or another cloud environment. So Vertex AI, this is a very high level overview. So we have seen part of it, but this is a bigger picture. Like we have data readiness, and we do feature engineering. So feature engineering can be done by, so this is feature engineering, AutoML. Let's say you have a use case around vision, video intelligence, natural language, translation, tables. So all these AutoML. So you may have to do feature engineering, then training, hyperparameter tuning. After doing feature engineering, model training and tuning of parameters, then you have model serving, because to make it any useful, you have to serve the model, and you have to understand again and then fine tune again. Then you may have to push to edge like mobile devices and all. Then you have to do model monitoring so that the quality hasn't degraded over time. And then you have all this model management, and then this layer like pipeline orchestration layer comes in. Like you have other features as well, like data labeling, feature store, which we have seen, training, data sets, Vizier optimization, experiments, AI accelerators, then prediction, explainable AI, hybrid AI, continuous monitoring, metadata service. And then below that you have this DL environment, virtual machine, deep learning, also virtual machine and DL containers. This is another layer if you want to go with deep learning, virtual images and containers. And then finally you have notebooks wherein you play around, you do some development, all those things. So this is very high level. It includes all the aspects which Vertex AI offers. So one thing, important thing is choosing the right tool. So I talked about pre-trained API, pre-trained, right? Pre-trained APIs. Then I talked about AutoML. So which one should we use? So do you have your own training data? So if we have absolutely no training data, like let's say you just start immediately, you develop an application, you want, you submit image, you want to detect what all objects are there. So no. And anyway, just go ahead with pre-trained APIs because you don't have any training data, so you cannot create a model. And if you have, yes, are you writing the model code yourself? So you have to ask if you want to write the model code yourself. If the answer is yes, go with custom model tooling. So this is where you develop custom model. And if you are you writing the code by yourself? No. If the answer is no, then you just go ahead with AutoML. So AutoML is you have training data, but you don't want to write any code. AutoML, you have training data and you want you are okay to write your code also. So you have very high level of control. So that's why you have custom model. This one you have less control, but it's faster. And the fastest is pre-trained APIs because you don't have training data, you don't have any coding expertise. So just go ahead with this. So I'll just use API if you don't have enough data and you don't need your own labels also. Your prediction task is general enough to fit into the type of labels provided by the service. You want to use labels from pre-trained APIs to train custom models with AutoML. Use AutoML if your use case fits into supported AutoML offerings. So because you have to see which all AutoML offerings are there. So image and video classification or object detection, text classification, entity extraction, sentiment analysis, tabular regression, classification or forecasting. Use AutoML if you don't need to know specifics about the underlying model and you want to develop a quick initial model to use as a baseline, which could end up being your production model. And last, build total custom model if your use case doesn't fit into any AutoML use cases. So if it doesn't fit in AutoML, or your model takes mixed input types like images plus tabular metadata, because it's a mixture of for example, images or video plus some tabular like imagine, spreadsheet, tables. You want control over your model's architecture, framework or exported model assets. For example, maybe your model needs to be built with TensorFlow. You already have a baseline or heuristic and you want to see if you can improve upon it. So because you have a baseline or some already have experience like how it should perform, so and you want to improve on whatever is already existing. So custom model training on Vertex AI. So this is the last part we are discussing, custom model training. So notebooks and deep learning VM images with a pre-installed Jupyter Lab environment powered by most common deep learning frameworks and libraries and the best in class computer power. So it could be TensorFlow processing unit, GPU graphical processing unit, and Vertex experiments and Vertex tensor board, Vertex training, Vertex Vizier to visualize model experiments, train your model in a managed and customizable fashion, and thanks to container technology, and optimize hyperparameters for maximum predictive accuracy. So just very high level MLOps. So this is something like a DevOps if you know DevOps. So MLOps is basically ops plus machine learning. So just think this left hand side is development. So machine learning development. So these are the very high, most like important phases or stages. Like you have feature engineering, you train a model, you evaluate a model, then you upload data. So first you upload data, prepare data, all those things which we have seen. Then you do feature engineering, train model, evaluate model. Then again, this cycle repeats, same like how regular development happens. And then if everything is okay, like you have the final model and you are happy with the accuracy of the model, and it goes to the deployment, and then you have the ops part. So this model, let's say you have run a few cycles, and then this model is good enough, and you release, deploy and monitor. So you keep, over a few months, the accuracy may go down or something, then you have to come back get some more data, then again release a new model, deploy, monitor. So that's why you have these two phases. So MLOps, so these features or these component of Vertex AI will be helping in MLOps. So it could be feature store, experiments, pipelines, orchestration, because it's the main component, and then continuous monitoring and metadata. Metadata could be like how was the accuracy, true positive rate, all those things, model accuracy. So these are the and metadata will be can be some information about the models as well, like what version, all those things. So the platform provides a robust MLOps architecture using managed services such as Vertex Feature Store, Vertex Pipelines, Vertex ML Metadata, and Vertex Model Monitoring. So next is Vertex AI Pipelines. So we are coming to the same like Jenkins pipeline, the Vertex AI Pipelines, or any CI/CD pipeline. So pipelines automate the training and deployment of models. So you have like extract data first, then you validate data, then you prepare your data, train model, evaluate, validate, and deploy. And then you go up. If you are not happy, then means that once you deploy, again you can train a new model as if you have new data and all. So this is like typical Vertex AI pipeline. So this is like if you are wondering how the UI interface looks like. So Vertex AI pipeline is, it's the whole thing is like very vast Vertex AI, but we are just seeing one of the part, like small pipeline. So you have, it looked like a directed acyclic graph. So this is one of the example pipelines. You have tabular data create, then you run some training job, then you classify model, evaluation metrics, you collect the metrics, and then you can put some conditions and you can deploy model. All those things you can visually see. And then when pipeline runs, you have the artifact, the model, and you have like what type, you can provide a name. So in this case, it's a classification, and where is the models saved, URI, and then you can see a confusion matrix, true positive rate, true negative rate. So this is labeling. So there are multiple labels. So this is true label, predicted label, and then you have ROC curve, one of the important matrix. It's basically receiver operating characteristic. ROC curve is a graph showing the performance of a classification model. The curve plots true positive rate versus false positive rate at different classification thresholds. So key capabilities of Vertex AI pipeline. So it's written in Python SDKs, and you can run as many pipelines on as much data as you want. Metadata and lineage store metadata for every artifact produced by the pipeline. You can track and debug pipeline executions. It's identity and access management compatible. VPC service controls and customer managed encryption keys you can provide. And you pay for the pipelines you run and the resources they use. So one of the important technologies is Kubeflow pipelines. So there are migration happening between Kubeflow and now Vertex AI pipelines. So Kubeflow, it may show up in exam. Kubeflow is one of the open source technology for running machine learning workflow on using Kubernetes. So Kubeflow pipeline platform consists of UI for managing and tracking experiments, jobs, and runs, an engine for scheduling multi-step ML workflows, an SDK for defining and manipulating pipelines and components, notebooks for interacting with the system using the SDK, and the goals for Kubeflow pipelines is end-to-end orchestration, enabling and simplifying the orchestration of machine learning pipelines, easy experimentation, make it easy for you to try numerous ideas and techniques and manage your various trials experiments, easy reuse, enabling you to reuse components and pipelines to quickly create end-to-end solutions without having to rebuild each time. So now next is AI platform pipelines. As I mentioned, they were migrating. So you have both the options. So AI platform pipeline save you the difficulty of like setting up GKE cluster, creating a cloud storage bucket, installing Kubeflow pipelines. With AI platform pipelines, you can set up a Kubeflow pipeline cluster in 15 minutes. So it can take care of all these things. It creates a cloud storage bucket to run pipelines tutorials and get started with TensorFlow extended pipeline templates. So these are the high level understanding pipeline components. You have the image location, then you have inputs, outputs. So these when you start a pipeline, you have of course an image, which Docker image it should run. You provide some inputs and you say where in the output should be saved, what name of the file and all, and then it goes and fetches the machine learning image and all. So for example pipeline. So these are for this whole thing is a pipeline. You have component. So a component you can label for example pre-process the data, train, predict, and then provide a confusion matrix or receiver operating curve. So these are separate pipeline component. In this case, it's producing 2 artifacts. So but both will be contained in a pipeline component. So high level flow to define and submit pipeline. So you have components which I mentioned. So you build define modular tasks as components using Kubeflow pipeline SDK with pre-built or custom components, and share components to reuse in other pipelines. So this is shareable artifact. And then you have workflow, which we can call as pipeline. Chain components to form a pipeline. So you have component 1, 2, 3, and you can just chain them together to make a pipeline. And Vertex AI pipelines, you just compile and submit pipeline to Vertex pipelines engine and ML metadata. So with that you can track. Vertex pipelines automatically tracks metadata and lineage. So concepts we have already seen. I have already talked about. This whole thing is a component. It has input. It has a container which is containing an application, and output. So this whole one component, 2 components. So this, let's say this is a starting component. You provide input, output will be fed into the second component, and then the second component will run, and then whatever output it gets fed into the third component, and this whole thing will be a pipeline. A component is a self-contained set of code performing a single task in a ML workflow. For example, training a model. A pipeline is composed of modular tasks defined as components that are chained together via inputs and outputs. Parameters are inputs or outputs to support simple data types such as string, int, float, bool, dictionary, list. Artifacts are references to the objects or files produced by pipelines runs that are passed as inputs or outputs. So some use cases. This is like a real-time ad targeting system. So you have ads corpus, you have starting corpus, and you have Vertex AI matching engine, candidate generation. It can generate multiple candidates, then you have re-ranking, all those things. And then for example cloud run, the client will connect, and this at the same time whatever the client or customer is, let's say they are browsing on the internet, it gets streamed into PubSub. It goes to data flow. It can perform some data cleansing or data preparation of transformation. Then it can feed into feature store. Again, this whole thing can be re-ranked based on the Vertex AI prediction, this model. And then same, the whole thing is served by Cloud Run in this case, which is offering an API, all those things, gateway. So this is one of the use case. One more feature which is like dual deployments in Vertex AI. So it can serve data model. So if you run like you have a data set, you have AutoML, you have created a machine learning model, then you deploy it, and there's an endpoint. This is a REST web-based HTTP endpoint, but you can actually push the model to an AutoML edge. So edge is for mobile device. So you can produce that artifact, and it get exported as a TF Lite, TensorFlow Lite model, and you can publish it to your devices so that they don't have to every time reach out to the endpoint. So this will be much faster. So it's a light component for limited functionality. So Vertex AI Workbench. So we have already seen that Jupyter-based, fully managed, scalable, enterprise-ready compute infrastructure with security controls and user management capabilities. Explore data and train ML models with easy connectors to Google Cloud's big data solutions. You can interact with Vertex AI in other Google Cloud services from within a Vertex AI Workbench instance's Jupyter notebook. Vertex AI Workbench integrations and features can make it easier to access your data, process data faster, schedule notebook runs. some examples: you can access and explore your data from within a Jupyter notebook by using BigQuery and cloud storage integrations. Automate recurring updates to your model by using scheduled executions of your notebook's code that run on Vertex AI, and process data quickly by running a notebook on Dataproc cluster. Run a notebook as a step in a pipeline by using Vertex AI pipelines. So there are two options. There's managed options. Managed notebooks instances are Google managed environments with integrations and features that help you set up and work in an end-to-end notebook-based environment, notebook-based production environment. So this is like managed Jupyter. You can just think like and there's user-managed notebooks like deep learning VM images instances that are heavily customizable and are therefore ideal for users who need a lot of control over their environment. So managed notebooks, where it is handy, are usually good choice if you want to use a notebook for data exploration, analysis, modeling, or as part of an end-to-end data science workflow. Managed notebooks instances let you perform workflow-oriented tasks without leaving the Jupyter Lab interface. So if you want less control but something very easy, convenient, then you go with managed notebooks. But if you want something, they also have many integrations and features for implementing your data science workflow. And then finally, user managed. You want total absolute control, can be a good choice for users who require extensive customization. Also, you need extensive customization, exact same libraries, you want to bring in new libraries, all those things, and who need a lot of control over their environment. Example like customizable deep learning, virtual machine instances. And that's all. Thanks for watching. Bye.